Hello, this is Chapter 3, Section 1, Part 2. So we're going to review what we learned in the first part, and then we'll start learning some new stuff. So we have some new data here. We're talking about Pixar Animation U.S. box office sales in millions. We have Toy Story 192, Bugs Life 163, Toy Story 2 246, Monsters Inc. 256, Finding Nemo 340, The Incredibles 261, Cars 244, Ratatouille 206, WALL-E 224, and Up at 293. So we're going to review histogram, mean, and median two different ways. We have our calculator. We're going to first input the data. So we go to Stat, Edit, and I'm going to put my data in list 3. So I put those numbers in, 192, 163, 246, 256, 340, 261, 244, 206, 224, 293, and then we're going to do first a histogram, see what the data looks like. So I'm going to go to the home screen by hitting second mode. Then we're going to hit second, y equals, go into number 1, because we're only doing one picture, turn it on, choose histogram, this time list 3, second 3. Frequency we leave at 1, move it up, 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 hit zoom 9, and there's your histogram. If I hit trace, you can see all the bars defined. There are 3 tall bars, nothing, and then 1 little bar on the right. So if I was going to say shape, it looks like it's skewed to the right, and base, it looks like we have an outlier, which would probably be Finding Nemo, which it is Finding Nemo. That's what's causing, that's the one that made the most money of the Pixar movies. Okay, so histogram, done. Since it is skewed to the right, the measure of central tendency that we prefer would be a median, but we're going to do mean and median. So 2 ways. Again, from the home screen, second mode, we can hit second, stat, go over to math, choose mean of list 3 this time, second 3, and the mean is 242.5. The median, second stat, to the right for math, choose median. Number 4 of list 3, second 3, close parenthesis, enter, 245. Okay, or if we want to do it all at once, we can hit stat, calculate number 1 for one variable statistics, second 3 for list 3, enter, and then the mean would be x bar, down, 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 the median would be 245. Okay, so that's all practice. Now we're going to learn something called standard deviation. And the standard deviation is a number that measures how far away the typical observation is from the mean. So basically it's the distance from the mean. The distance from the mean. Now, here is the formula. I know it looks a little scary, but really it's not that bad. So to find the standard deviation, S, symbol for standard deviation is S, you take the square root of the summation, each observation minus the mean squared, add them all up, divided by n minus 1. So here's basically in symbols the process to find standard deviation. You take each observation minus the mean, square it, do that for each observation, add them all up, divided by n minus 1, and then you take the square root. Okay? So to do this, and I have it all worked out for you, step 1, find the mean. So you add them all up, divide by 10 observations, we have our mean. So what we're going to do is we take each observation minus the mean, each observation minus the mean all the way down. Once we have those differences, you square it. And the idea of squaring is to get rid of all those negatives, to make them all positive. Then we add them all up. Then we take that sum and divide it by n minus 1. Now just a little trick here. Notice this side, if you just subtract each one from the mean, and added those up, it'd be 0. This is a nice way to check if this column is right before you move on to this column. So again, subtract each one from the mean, square it, add them all up, divided by n minus 1, and then when you do that, you get this large number, 2,571.183, but remember we're not done yet. We squared them all, now we're going to square root them, and we get our standard deviation of 50.71. So let's do it in the calculator to check it, and we'll talk about what it means. So in the calculator, how do we find the standard deviation? Well, you already know how to do it. It's the same way we find mean and median. So we do second, stat, over to math, but this time we choose number 7, standard deviation of list 3. There's your 50.71. Or we could do stat calculate one variable statistics of list 3. And there's your S, X is your observations, 50.71. Now remember, what does this number mean? It means the distance from the mean. So your average is 242.5, and the average difference, the distance from the mean, typical, is 50.71. We'll talk about how we use this, but for right now, think about it as distance from the mean, distance from the mean. Okay? So, a couple things about standard deviation. Standard deviation measures spread by looking at how far the observations are from their mean. The variance, it's the same thing without the square root, is the average of the squares of the deviations from the observations from their mean. We generally find variance as a step towards finding standard deviation. Again, all of your steps written step by step. There's the first method, and there's the second method. Okay, now some information about standard deviation. Notice that both of these are skewed to the right, but the standard deviations are a little different. This is 5.6, this one is 3.2, so even though they have the same shape, this one has a larger standard deviation. Why is that? There's more that's spread out. See here, there's kind of more than down here. Since there's more that's spread out, higher standard deviation, spread from the mean, spread from the mean. Okay, then we scroll down, and here's some information about standard deviation. So remember, standard deviation measures the spread about the mean. We only use when the mean is chosen, so mean and standard deviation go together. If there's no spread, so for example, all of your data was 5, 5, 5, 5, 5, 5, 5, 5, 5, there's no spread, standard deviation would be 0. The more spread, the larger the standard deviation. And S, standard deviation, like mean, is not resistant. What that means is if you have your data close together, you'll have a small standard deviation. If you have one number that's outside, that's going to make your standard deviation large, just like a number on the outside will make your mean large or small, depending on where it's at. And strong skewness or few outliers can make S very large.